I was a customer of Event Store. I became the CEO of Event Store, and so that's what I'm doing now as CEO of Event Store. But one of the things that I came across when I was there, some of you might have seen this diagram. This is from Gartner, and this is about event-driven. Gartner has named event-driven architecture as one of the top 10 trends, so it's got buzz in 2018, and the same for 2019. And they talk about this idea of businesses and enterprises moving from a state-driven view of the world to an event-driven view of the world. And I'm going to talk about that a lot, this idea of state versus events, and what those would be and how they would relate. But when Gartner talks about it, and a lot of the talks that you see, they're talking about event-driven in the large quite a bit. They're talking about events between systems. But what I want to talk about with event sourcing tonight is more about the systems themselves being event-driven. And some of the benefits of that, and the paradigm shift in actually how you build systems, not as much how you integrate between systems or how you get data from one or more systems out in, say, a data lake or for data analytics. This talk is not so much about data analytics as it is about if you're going to build a new system or bring your systems to a new architecture. This might be an approach that you might want to consider as an architect yourself in your toolbox. So let's talk about what event sourcing is. And actually, it's a pretty simple thing. And the idea behind event sourcing is that rather than storing state, which you do in most of us who've written systems in the last 10 or 15 or 20 years, you wrote to a database, and when you wrote to database, you saved the current state, and you sort of threw away what was there before and put what was the new state in. And with event sourcing, rather than storing state, the idea is to store the changes to state, and then derive state from this change history. That's it. I mean, that's what event sourcing is. It's a pretty simple idea. Now, these state changes here, for the purposes of this talk, I'm going to call them events. Events is a term that's used in a broader way quite often, but quite often it is also used to mean, in event sourcing sort of semantics, it means a state change. And for this talk today, events and state changes, or recording that a state change occurred. So I'll talk about that quite a bit in coming slides. Of course, one of the key aspects here around event sourcing, and one of the key benefits, and I'm going to talk about others, is that there was data that was lost when you just stored state. For example, in this example where we have these events, these changes in state, a shopping cart created, socks added to the cart, a shirt added to the cart, the socks removed from the cart, and then the checkout. You don't have, if you just keep the latest state, you've lost the information that you ever had socks in that checkout, or in that cart, I should say. So, for example, in some event sourcing talks, you'll hear people talk about that CRUD isn't really CRUD. CRUD is really CRDD, meaning even when you do updates, you've actually thrown away the old data, so you've actually deleted data. It's not. And so that's a big part of this, is not losing data. And I'm going to talk about how you build these types of systems, and also some of the benefits as we go forward. So I asked this early, who uses event-sourced applications, and some people said we all do. Well, one event-sourced application is Git. So if you use source management, this idea of keeping the deltas and be able to blow away the application, the state, and replay and get the state at any time is one of the inherent capabilities of a event-sourced system. One that I want to talk about more is relational databases as event-sourced systems. And for me, this is one of the things that pivoted me and got me to kind of take the red pill and see things as possibly a new way of writing, a new paradigm, a new way of writing systems. There was a talk by Martin Kleppman, who the Confluent people know pretty well, I think, at Strange in 2014 called Turning the Database Inside Out. And actually the whole title is Turning the Database Inside Out with Apache Samza. But the part I want to emphasize is actually some observations he made in this talk around relational database. And this idea, every relational database has, not every, and there are some varieties, some ways you can work around this differently, but most relational databases work from a commit log. So changes to state are written to a commit log first, and then projected, arguably, I'm using that word purposely, to a third normal form database. And what Martin says, one of the things he says is, what if you, first of all, what's the more atomic data source here? It's clearly, as I mentioned, you've lost some data in the third normal form database if you delete data. And you can get this database by replaying any time. So if you were to suspend disbelief for a moment that you could actually get performance, clearly we did this. And actually I used to work for IBM and I used to sell relational database, and a lot of my job, I remember, was selling the attributes of relational database, which was the prior data models like hierarchical databases. You had to already know how you were going to access the data. So relational databases allowed you to go in on previously maybe unpredicted ways of assembling that data and give you the most flexibility. And from my perspective, this has a lot of similarities, that now you're able to replay this data. And what he proposed was, what if you instead thought of the idea of using this as your atomic data source, the commit log, as your actual data source, as your source of truth, and then having optimized read models for the read approach. And if you could do that, and there's a lot to this, yes, I think a lot of people could agree, if that was possible with great performance and easy to do, that would be ideal. But even the idea that you could think this way, for me, this was mind-blowing to me. This idea that this might be the core data structure, and if you could figure out a way to build systems that were performant, then this really could represent a paradigm shift. And I'll tell you, there's some other things where this plays into, like microservices architecture. A lot of modern trends make this all the more relevant, I would say. So this just happens to be the diagram that he's written in the Confluent type. I would love to figure out how to do these Confluent diagrams. You guys share that? Is that a secret? It's pretty much repeating what I just said. So just some quick history about event sourcing. Some people, when they talk about event sourcing, and Alex, I know you've heard this, they go way, way back. They talk about Mesopotamian clay tablets and write once, and append-only type of approaches, and Venice shipments, bill of lading, which was like early occasionally connected systems, but they were ledger-based, so when you came back, you had some hope of synchronizing. And certainly accounting ledgers. Accounting ledgers is truly an event source type of model. You're adding to the accounting ledger, and the balances just happens to be derived from all of the entries in the journal. So these are event source type information systems, as Adam would use. So Martin Fowler in 2005 talked about capturing all the changes to an application state as a sequence of events. The person that I'm most familiar with is Greg Young. He's probably the most prolific speaker and writer, I would say, on this subject. He's a co-founder of EventStore. He wrote version 1 of EventStore. And in the 2004-2005 timeframe, he was working in the Pacific Northwest, up in Vancouver, BC, doing high-speed trading systems and gambling systems using event sourcing. And actually working with, he's not here, but he would have been here, Alex, CEO of Adaptech. Adaptech, right? Adaptech Group. But he's a friend of the Seattle Event-Driven Meetup. He runs the Vancouver Event-Driven Meetup, and he worked with Greg and is very prominent in the industry as well around event source systems. Greg came out in 2007, I think the first time, talking about CQRS and ES together. And I'm going to talk about how they could fit together, command query responsibility segregation. Don't worry, we'll talk about that term in a moment, around building these types of systems. And in 2012, EventStore 1 came out. But if you Google Greg Young, you will see tons of talks. He's very articulate about this event sourcing approach, and he's the one that really popularized event sourcing, I would say. So it's 2019 now. What's the state? What's going on with event sourcing? Well, if you go and do a query on YouTube, which I did just a few days ago, and to my surprise, there was like 1,000 videos. I started to do the API, writing the API to figure out how to actually get the number of videos, but it was much harder than I thought it should be. So I didn't get it, but I kept paging and paging. There's tons of information out there, articles, and some of it about disaster stories, some of it about how to do it. So there's a lot of buzz. There's very few books. There's no books that I know of with the title of event sourcing. There are books, and by the way, I'm giving away, there's 3 books. This book by Alexei Zimmerov is really good. It should have been called Event Sourcing, but it's not. It's called Domain-Driven Design with .NET Core. And there's an F# book, which it looks like a couple people already picked up, which is fine, which is good, around this. And there's a few more out there. But I think it's very interesting that there's not books yet written around event sourcing. And a part of my theory with this is that a lot of event sourcing actually came out of the domain-driven design space, which the domain-driven design world is a niche within the application development world, and event sourcing is a niche really within the domain-driven design world. But of the last, say, year or two, and Confluent has contributed a lot and helped with this, there's starting to be more of a talk about event sourcing itself and the value of the data model aspect of it, the data management side of it, that having a non-lossy data structures, that's the point. And domain-driven design and these other approaches, they're one good mechanism. There's prior art here for how to build these types of systems. But the point really is actually getting data. Can you actually build systems that get this data layout for your source of truth, and that then you can leverage that in your enterprise? So there are a few frameworks. There's more than I have on this, and I apologize, I should have put more on here. I've got Event Store, selfishly. There's another company. Event Store is just an event store database. It's just dedicated, and I'll talk about that a little bit. Axon IQ has both a framework and an event store, but there's very few, and most of you probably wouldn't have even known those names unless you already built systems doing this. So it's not prominent, the frameworks themselves. So there's a lot of buzz out there, but there's little knowledge of actually how to implement these systems. I challenge you to actually go do Google and find a very good description where code is written. You can do it. It is possible, but it's a challenge to find out what best practices really are for this. And so this is one of the things that we need to work on in this industry, is how to get more prescriptive and more common knowledge about best practices. And this is really important because there are dragons here. What we're talking about is distributed systems. It's not easy. So it's one of the things we need to do industry-wide is to improve that. There is a lot of people successful. I apologize, I blurred out all of our images, but this is the out-of-date set of customers for Event Store. I encounter on a daily basis extremely successful companies using this. They're getting remarkable competitive advantage out of it. One of these, which I didn't have to blur out, is Jet.com. The purple one up there is Jet.com, who runs Walmart's technology using all this approach for using event sourcing, the event store, and Kafka. So there are success stories out there, quite a few. I'm going to go quickly through the benefits, like do you have a question?
Yeah, like when you mention competitive advantage, like could you please be more specific?
Okay. I'll do that. So when I talk about these benefits, I think you'll see what I mean by competitive advantage. Because the sirens call, and I use that term purposely for event sourcing, is very, very compelling in my view. So one obvious one is audit. If every state change, the only way you can affect a state change in your system is through these events, then you have a perfect audit log just naturally when you build the system. And I've heard speakers even say, this is actually, if audit is your main thing, this was the only time you use event sourcing. And that has not been our experience at Event Store. I would say probably 10 to 15% of the customers of Event Store have chose it just for audit purposes. There's a lot of other benefits in addition to audit, but audit is one of the most natural ones that come out of it. If you get this stream of events, then you can go back and look at those, and you know it can't be circumvented. Time travel is another. So you have this stream of events. You can now move back in time. You can go pull that into a test environment, a dev or test environment, and replay and recreate scenarios. You can do what-if analysis. There's a huge amount of opportunity with this idea of time travel because you kept all the different states throughout time. Another is root cause analysis. This is sort of related to audit, but usually when you implement these things, you'll put the whole stream of events that cause other events. So you have correlation. You have the ability to look back at the root cause for a particular event. Replay is one of the big ones of value. So it's inherent in the architecture. This ability that you could replay through the state and reshape data. So if you had an unknown business requirement, you can reshape and derive these derived data models in ways that you didn't expect from the beginning because you didn't lose the data from the start. So now you can both, and the advantage that you can both have read models that are optimized for the read scenario, but also that were something you never predicted when you started. Async first, which is both a benefit and a part of the criticism as well when I talk about the challenges side. But these systems tend to be, you have a consistency boundary that is just what you write, and then everything else is eventually consistent. And you'll see more what I mean there. This has positives because you get more responsive, more scalable system, but there's trade-offs too because people aren't familiar with working with eventual consistency. And there's some special, you have to be pretty smart on some of these things and be thinking in a new way for eventual consistency to make sense. So streams, so real-time streams. If you were writing databases, I mean, this is obvious when we have Confluent here and the folks that are in the event-driven community, that if you wrote a traditional system, there is no streams backing it. There's not visibility of all of the changes that are going on in the system and no way to hook into that. So now when you have an event source system, you can hook into streams. You can put things like complex event processing, AI, AI triggers. You can hook into other stream-oriented technologies such as Kafka or Spark or Flink. All of those things it's extremely compatible with versus a lot of times you see folks sort of crowbarring in their traditional monolithic systems on relational databases and trying to get the event information out into their larger event-driven architecture. Legacy migration, which I think this is surprising sometimes to someone. This was actually one of the motivators that I had at Line Data and what I've seen in many companies. This idea that you could take a monolithic legacy application and split off a piece of it and then direct just the commands into that piece, just the updates into that side, and then have a read model going back and do that in a responsible way so that they can synchronize. That fits very, very well in event sourcing approaches. So I think that's been called the sidecar model, and then you can combine that with the strangulation pattern where you could do that one by one on your monolithic system and move off of the legacy system. And surprisingly, a large number of the customers that I've seen are actually, this is a major motivator for them because everybody has legacy systems, right? And they want some way to incrementally move out of them. I've alluded to this already, that event-driven architecture congruence, but this idea that if your enterprise has adopted an event-driven architecture strategy and you're trying to use events and choreography outside of your systems, it's a lot easier if your source system is also event-driven. And we run into cases where that has not been implemented. So you run into issues such as something comes up in an event in the larger event-driven architecture, but it was 5 days ago that you ran into the problem. Well, how do you reconstruct that state in the other system? Or the event mechanism you've kind of put in for your traditional system gets circumvented because someone writes something directly to the database. So you have audit. You now need to audit back because not everything, you can't be completely sure that the event-driven approach has been taken, or those events that you're creating out of a typical system have been honored. Observability, again, this also has a side effect of more moving parts, but because commands and events are flowing through queues and through streams, you have the ability to observe all of these things. You can put dashboards in place that allow you to see your system better. Okay, and then 3 more. One-way data flow. The only reason I put one-way data flow out here is that if anybody's sat through a React talk, through a React Redux talk, they just say one-way data flow and everybody nods and says you can reason about your data better and everyone says, yeah, that's great. I never completely understood that, but you get one-way data flow in this, and you'll see when I show you the implementation pattern, you'll get a one-way, you build these things with a one-way data flow. Microservices enabling. So one of the things that you'll see quite a bit of literature around using event sourcing in a microservices architecture approach. And where it could be a valuable tool is when you want, of course you want autonomous microservices. And there's different ways of accomplishing autonomous microservices, meaning all the way down to the data level. So you're not sharing a global database. You want it all the way down to the data level. So one approach would be to actually have a read model that's out of, say you have a source system of data, and you have another microservice that is depending on that, Rather than it doing HTTP calls and having the coupling issues and the uptime issues of doing HTTP calls, it caches the data. And because of with event sourcing, you can keep track of where you are. If one system goes down, when it comes back up, it can resync back to current. And this is one of the fundamental capabilities of an event source system. So this is very powerful in microservices types of approaches. And finally, event tolerance. Because event streams are fundamentally logs, they fit very well with backup, disaster recovery, and backup type of scenarios. Okay, so I threw a lot of benefits out there, and some of this is idealistic. There's a lot of complexity that goes with building a subsystem as well. Now, but one thing that happens, I think, and you see this a lot in some of the discussions, is some confusion between complexity and lack of familiarity. And so one aspect of event sourcing is it is a very different way. When you build these types of systems, it's very different than what a lot of us have been taught to build systems. When you just put a relational database and you had a middle tier, maybe an ORM, it's not, you don't use that approach for building these types of systems. It tends to be more like a functional programming approach. And also, as I mentioned earlier, there's a lot of prior art in domain-driven design. So sometimes when you're reading these articles, you'll see things that are specific domain-driven design, and it can be kind of confusing. Those aren't inherent in the complexity, they're just lack of familiarity. Now so complexity though is a real thing here. It's a distributed system. There's more moving parts. There's an async. As I mentioned, you're going to build systems with async in it. So which is, as you know, async is very valuable and important, but you have an eventual consistency issue. Even when you write a UI in an event source system, there's ways around this, but generally, the UI that you're looking at, say you're showing data and you're also updating data on the same single-page application, the UI is going to be eventually consistent. I'll talk about it in the way implementation works. So this is something you have to deal with. Oops. Actually, I'll keep that up. So versioning, because you're keeping events all the way back to the beginning of time, versioning becomes an issue. Now, this is one thing, Greg Young was going to write a book forever. He's still going to write a book on event sourcing. But the one part of the book that's out there right now is called LeanPub. Rob Brule's talked about it. If anybody saw Rob Brule's talk back, he talked about it, about how to do versioning. There are prescribed approaches, but it's contextual. There's a lot of different approaches you might take based on what your business issue is, but you have to deal with versioning. In a way, when you just threw away state, you didn't necessarily have to deal with. And then developer tooling is not as far along as it should be yet. Now, the only thing here is that when people talk about complexity, and you will see this, if you start looking around on the internet, you're going to see a lot of discussion about complexity. A lot of it is legitimate. But oftentimes, in my view, what I see is they're comparing, what are they comparing it to? They'll compare it to a CRUD-based simple system and say, don't event source that. And they're right. If it's going to stay a CRUD-based, and that's all you need, don't apply event sourcing. But also what happens quite often is they start off with that approach, and then they want history. They want so they create an audit table, you know. And what this starts to lead to this issue of accidental complexity, where you start with something simple, but rather than using a pattern that was built for the approaches, you actually use other patterns. You end up sort of hacking around in order to solve those issues, and you end up with more complexity. And so that's a part of the challenge here. So I want to talk about implementing event source systems. There's a lot of times you'll see this talk that I just gave in some form all over the internet, really. But there's not that much talk about how to implement these things. And we'll see, I'm not going to be able to get into code or anything, but I want to talk some about the sensibilities of implementing an event source system, kind of what you think about. And this is where I'll bring up this other this acronym, CQRS. Who's heard of CQRS here? Pretty much everybody. And it's quite popular right now if you look at React or Angular. And so it's a pretty simple pattern where rather than doing reads and writes through the same channel, the idea is just split up reads and writes. So commands are on the right side, so for writing, and queries would be on the read side. And the reason for doing this would be that you could optimize the write side, which quite often is much fewer than the read sides. Oftentimes as much as 90% you'll be reading in comparison to writing. And if you look at relational data models as an example, they're not really optimized for reading at all. You reassemble what you're reading every time. So Greg Young talked about this in 2007, this idea of splitting it up, and he's got some good talks about the advantages of this. And this is the thing about the one-way data flow that I mentioned, for reasoning about data. So now event sourcing, it does not have to be involved in a CQRS context, but I'm going to talk to you and try to explain why I think it oftentimes should be. And this goes back to, oops, I won't go that far yet. We mentioned what events were before. I defined an event in this context as a state change, right? So this represents some state change that occurred. And a command, which I said was an update, it represents a request for a state change. You can think of that as you're requesting, or your intent is to add 2 pairs of socks to my shopping cart, right? So somewhere in there, if you're in a line of business system, there needs to be validation of that. Is it valid for you to add two pairs of socks into your cart? So something needs to do that. And this is where commands helps you, in my view, as a pattern for thinking about how to get events in. Many of the talks that you see around event sourcing or event streaming or event-driven architecture, they start with an event's already happened, and sort of, in my view, sort of magic already happened, and then they talk about all the value of events, and then they talk a lot of issues, which oftentimes were related to how you got the events in the first place. So the general idea here with event sourcing with CQRS is commands come in, they go through some sort of validation, they are then, if the validation is successful, turned into events. Listeners listen to the end of that. They could listen to other parts of it. And then they create a read model that's appropriate to what they need. That could be, they could persist that in a relational database, they could persist that in a graph database, they could have an in-memory read model, which is what your UI will typically do. That they could hook up with an external stream, a Kafka stream, to work with in an enterprise, for example. So I won't go too far in this, but on the right side, commands and events. So as I mentioned earlier, commands need to go into some sort of validation, and then the result is some events, or they get rejected. So a command is a request for a state change. It's usually phrased in the imperative when you implement this. So in this case, add to cart. It actually should be with a question mark in my view, because it could be rejected. It's like, can I add to the cart? So it can be rejected. That's a key thing to remember about commands. And then they've got to be validated, and then they result in events. Events represent a state change I've already mentioned. They're phrased in the past tense typically, like added to cart. And they can't be rejected. At the point it's an event, it's an immutable fact. And there's all sorts of benefits that come from that, from immutability, from this ability now to cache these throughout in many different places. They can never be changed. They've already happened. So I've been using this term state change and represent very purposely, because this thing in the middle, this that does the validation, is ultimately a state machine. It's got to go through and figure out whether is it legitimate to take this cart from and add to quantity 2 to that state machine. And so this is one way, and if you were to look at this book, Alexi's book, this would be the approach, because he's used an optionary language. One way that's typically handled is you have a command handler. So I won't go into how a command gets routed to a command handler. There's an infrastructure that's involved. You can imagine it goes through some port in a hexagonal architecture or something to get to a command handler that can handle this type of command. And ultimately it's going to go to the state machine. By the way, the state machine has other names. It could be called, state machine is sort of a complex name, and I use it because that's what it actually does. But it's actually usually called something like entity or aggregate or stream controller or event-driven state machine. But really what it is a state machine that's got to check whether is it valid to go to the next state or not. So the command handler's responsibility is first to get that state machine up to the current state. So to do that, it goes out and reads from the store the events necessary, and suspend disbelief on performance for a second, but I'll talk about it. Is it reads all the events for this store. Now in this case there's only 4 of them. not a big deal, replays them through the state machine so that it's up to current state before the command has come in. And then the next thing it does, it asks the state machine then to validate, is it appropriate, can I move from this one state to another? Now, this is just a fancy name for business rules. This is, is there a business rule that would make it not valid for me to put 2 socks in this cart? That's all that means, and that's how it shows up when I show you the method that it shows up in code. And then, assuming that it's successful, it goes and writes these to the end of this event, or there could be more than one event, to the end of the event store. It appends it to the event store. This becomes really important in event store systems because this is the only consistency boundary. And so getting this consistency boundary right becomes fundamental in designing these types of systems. Everything else that's reading off this is going to be asynchronous, is going to be eventually consistent. So all the read models. I won't go into this too much, but a state machine is very simple. It has member variables, it just looks like a class that has some member variables. It has some methods that are necessary for every event to move it through the state, to change the state, and it has some methods to do validation. That's it. And a lot of times when you're writing these systems, this is all you really need to write. Most other things are well, except for when you get into advanced scenarios, which are boilerplate or infrastructure related. Okay, that's the read side. Now let's talk about, that was the right side. Let's talk about the read side. So now you see the right side is completely decoupled from the read side. And so now what you have is this set of events. Notice that they have a sequence number. And you have subscribers to these events. And I've already mentioned this, so I won't go into it in much more depth. But you could have an in-memory read model, you could have a persistent read model, etc. On the read side. There is a sort of unique thing that you get in these types of systems, which is a catch-up subscription. And you can probably imagine how valuable it would be. And it's critical for understanding, like, for example, if you created a new read model, how do you get that all up to speed? How do you get it all hydrated and created? And quite often you'll use a catch-up subscription to do that, which is just subscribing from some location. It could be start, it could be the last place that you synchronize when if you're a microservice. So it's subscribe all the way from that location and then up to now, up to current, and then be notified of every new event. So let's talk about design of these types of systems. One of the things I think is most exciting about this is some of the work that's being done, some of it by our friend Adam Dimitrick, but there's event storming and event modeling. This guy here is Alberto Brandolini. He's done a bunch of work around using events as a way to talk with the business about the business and capturing that in terms of events and using a common language to do that on a timeline. And Adam Dimitrick has taken this even further and taken this into actually creating artifacts that can be used directly translatable into building these event source type systems. And we'll have Adam come down. Adam actually talked 2 meetups ago about event modeling. I'm sure we'll have him down again. But I think this is moving the industry forward quite a bit because one of the big values, not just not losing all of that data, but it's putting that in a way that the business understands and having the business actually be able to see these events as well. And then in terms of domain-driven design, there's some very useful concepts in domain-driven design. I don't think that necessarily domain-driven design is the only way to build these types of systems, but there's some nice, valuable things out of domain-driven design. One is this idea of ubiquitous language, this idea that you're using in the code and all the way down to your development artifacts the same words and that your business is using. Another is bounded context, which is very useful for understanding like what services you're okay with having more tightly coupled, and which ones you can't have. You absolutely do not want to be tightly coupled because they're a part of a different context. So when you're doing a microservices type architecture or a services-based architecture, that can be very useful on the design side. And then the other is the idea of aggregate, this idea of what the consistency boundary could be and how to think about that. Domain-driven design has some nice ideas about how to figure out what that boundary could be. Okay, and I'm wrapping up. This is the last part of this on persistence options. So you may have gathered from the talk that a message bus, you wouldn't use a message bus for this type of scenario. You'd use some database technology. And so the requirements for this, well, they're database, things you'd expect out of a database: guaranteed writes, a concurrency model, transactions, retention, no retention period really. And then also, so on a database, but also then a stream API on top of it, because you want to do things like append to a stream, and you want to be able to subscribe from a particular position, for example, like you'd want in a stream API. And then another, which is useful, there are ways to work around this, but is granular streams. Is at Event Store, we have customers that have millions or billions of streams per cluster. Because if you can hydrate, you want to be able to quickly replay that state machine at the entity level. And so those are things that you'd like to have. They're in Alexi's book, he listed ways you can use different database technologies. So you can use a relational database model for this. You can use a document database for it. You can use columnar type databases for it. But and then there's a few specialized databases like Event Store and Axon Server, and there's another one called Rails Event Store. I know there's more, and I apologize for not having all those at the tip of my tongue. Kafka is also at times used, but I see Kafka currently still more used for the sweet spot of event distribution, and in particular, and sometimes an event sort of transfer, what Martin Fowler's calling event transfer, system to system. But it has a lot of characteristics as well. So, as I mentioned, Event Store is an open source technology. Feel free to try it out. There is no cost for going to production. There's many production systems out there that don't pay Event Store, the company, anything, so that's fine. And there is support from Event Store, my company. So that's it. I think I have 5 minutes for questions, if anyone has questions. Yes, you're going to scare me because you already know.
Actually, so we have an event source system, and one of the things we're trying to deal with right now is around privacy regulations and PII.
Yeah.
And once you have events everywhere, that data is also everywhere.
Yeah.
So how have you seen people manage that?
The one that, so this question around managing PII, I know GDPR, I know answers for GDPR, which is one of the, which I thought you might ask, because that idea that you need the right to forget when one of the inherent capabilities of these event source models is to remember. And there's strategy around encryption, which lead to key management issues, but there are sort of known approaches for that. I'd have to get back to you on PII though. I actually don't know. It's a good point. And this would be true. This issue exists beyond event sourcing, because anytime you have data lakes and we have data engineers in the audience, the same issue occurs. That's a good question. I'd like to know. I'll work on getting that.
CCPA comes out next year.
What's that?
The California version comes out next year.
Oh yeah, the GDPR.
Yeah,
Yeah,
basically the same thing.
yeah, yeah. Any other questions? Yeah.
When you start talking about state machines,
Yeah.
it sounds like a complex problem when you want to guarantee the consistency, when you want to read stream of events, calculate the current state, and maybe emit more events, but you
Yes.
want to do everything in one transaction, right?
Yeah. And
Because otherwise you have multiple concurrent contradicting operations.
is through design strategies and through business domain strategies. There is no, and I've seen many systems that are built this way successfully, so, and your point is well made about this concurrency, this issue of if you have, what if you need, if I can restate what you're saying, what if you have the circumstance where events, multiple events, or events that have listeners that then kick off with more events, which is absolutely very common to occur, and you want all of them to be consistent. That is not a characteristic of these event source systems. That's why I'm making the point about consistency boundaries. And so what ends up happening is, and there's a set of strategies on the design side for assuring that that is the only consistency boundary. So the only state machine that you're doing is for that aggregate or that entity. Your is eventually consistent. There's some research going around something that, like consistency rings, this idea of being able to declaratively do consistency models, but it would not be in the same approach. It would be still eventually consistent, but putting blocking in front of eventual consistency. And so it would not have the same characteristics. So that's a great question and point. It becomes the art of how to build these types of systems. Ultimately is how to determine that consistency boundary. So, well, point well made, yeah.
Are there any systems that you consulted on or people have asked you about where the aggregate, where you need that consistency boundary is just too vague?
I have not encountered, I've heard a story of one, but I have not actually encountered it. And so this is where the advantage of the prior art that I mentioned, because this came out of this. So there is, well, domain-driven design has been around. I don't know how long it's been around. Well, since the 2004. I don't remember when Eric Evans wrote the book. And that is a place for inspiration on how to look at these types of approaches. And these are the subtleties. Greg Young speaks many times. For example, many things are asynchronous and don't have transactional boundaries right now in the real world. And Greg has great examples of that, where we expect more out of our system than what actually happens in the real world, of which there's already tolerance in the real world for this eventual consistency model. And this is sometimes the way you deal with this types of issues. So you use compensating, things like compensating strategies, and you break those things up. All right, we need a break for Robin to get set up. So we'll take like 10, 15 minutes, and then we'll let Robin go. Thanks a lot, everyone.